We call surface of revolution the result of rotating a planar curve around the fixed axis. The formulas to find the surface are the following. If the curve rotates around the x-axis from A to B,
A is equal to 2 pi the integral from A to B of f of x times the square root of 1 plus f prime of x squared times dx.
if the curve rotates around the y-axis from A to B,
The area is going to be 2 pi from A to B x times the square root of 1 plus f prime of x squared times dx. So now let's have an example. First of all, we move this right here so we don't lose it. And now
find the area of surface of revolution when rotating the curve f of x equals square root of 1 minus f squared over the x-axis between x equals 0 and x equals 1.
so the first step is to derive the fx, well, the function. So f prime of x is going to be we will write first the function, so it is going to be easier for us. 1 minus x squared, the elevation of 1/2. Then we move this 1/2 right here, so the function is going to be 1/2 1 minus x squared times 1/2 minus 1 times the derivation of the inner function, so it is going to be times minus 2x. Now we rewrite the function, so it is going to be minus 2x, minus 2x over 2 times 1 minus x squared and 1/2. So this is going to be minus 2 over 2 square root of 1 minus x squared. Now we apply these rules, so the area is going to be 2 pi, the integration from 0 to 1, the square root of 1 minus x squared. We close the square root of 1 plus minus 2x over, we could cancel out these 2's, so it is going to simplify 2 minus x over the square root of 1 minus x squared times dx. So the area is going to be 2 pi, the integration from 0 to 1, the square root of 1 minus x squared times the square root, this is squared, the square root of 1 plus x squared over square root of 1 minus x squared the square times dx, and this square root could be cancelled. So we have to simplify this equation. Knowing that are the same degree, we have to multiply this function into the inner function of the second square root. So the result is going to be a it's equal to 2 pi the integral from 0 to 1 of the square root of 1 times 1 minus x squared plus 1 minus x squared times x squared over 1 minus x squared. We close the square root times dx, and this is going to be cancelled out, so the result is going to be a it's equal to 2 pi from 0 to 1 the square root of 1 minus x squared plus x squared. They are going to cancel out, so we have now that the area is going to be 2 pi from 0 to 1, and the square root of 1 is 1, so times the x. So now we solve the integral, and the result of the integral is going to be a is equal to 2 pi x evaluated from 0 to 1. And now we evaluate this equation.
Solving the equation, the result is going to be area is equal to pi times 1 minus 0, and we cancel out this, and it's equal to pi times 1, that it's equal to pi, and that's it, just the units.